everybody! Today's practice problem comes from Principles of Microeconomics, 6th edition by N. Gregory Mankiw, and we're going to be doing Chapter 14, Problem number 8. The problem starts by giving us some information. It says, a profit-maximizing firm in a competitive market is currently producing 100 units of output. It has average revenue of $10, average total cost of $8, and fixed costs of $200. So the first thing we want to think about is, what does it mean to be in a competitive market? And we said the competitive markets were markets where there were a whole bunch of small buyers and sellers, so that the sellers and the buyers could to some reasonable approximation, take the market price as given. Sellers can sell as much as they want at the market price. They don't have to lower their price to sell more. And buyers can buy as much as any individual could reasonably buy at the market price, and they won't have to worry about pushing the price up with their demand either. So we can think here, we can write down what we have, and then we can see how we can answer the questions that are going to be asked. So here it says currently producing 100 units of output. So I'll put little q for individual firm output, star, because we'll assume that they're currently producing the quantity that's profit maximizing for them, which we indicate by a little asterisk here. So they're producing 100 units of output. They have average revenue of $10. So you can put AR equals $10. Average total cost of $8. So ATC equals $8. And fixed cost, or total fixed cost, of $200. So that's all we know so far. And we could think about, based on this, obviously, we could say we know average total cost. We could come up with total cost by multiplying by quantity. We know that in a competitive market, average revenue is just the revenue per unit that we're getting is going to be the same as price, is going to be the same as marginal revenue, and so on and so forth. So we can think about what else we can do with these quantities when we're asked. So the first part of the problem says, what is the firm's profit? So we could do this in a number of ways. The most basic is the profit is just equal to total revenue minus total cost. So we could go through and we could figure out, okay, what's total revenue, what's total cost, and we could subtract them. And that's totally fine. We could also notice that more commonly when we're talking about profit, we find it useful to represent profit as quantity produced times price minus average total cost. And this has a nice interpretation because price minus average total cost is just what your profit is per unit. So you're going to profit per unit times the number of units that you produced. So if we think about it this way, we have most of the things that we need, right? That we know that our quantity is 100. We know that our average total cost is 8. So the only thing we need to fill in is this price. But one of the things that we said, because in a competitive market, the firm is just selling as much as it wants at the market price, then we can say, if our average revenue is $10, that means that for each unit that they're selling, they're bringing in $10. Well, if they're selling all the units at the same price, it must be the case then that the price of the output is also $10, right? Because we could just see average revenue here would just be total revenue divided by quantity, which would be price times quantity divided by quantity, which not surprisingly is price. So then we can just put that price over here, and we see that our profit is equal to 100 times 10 minus 8. So we're going to see that our profit is going to be $200. The next part of the problem asks for the firm's marginal cost. So what it's really asking for is, what's the marginal cost of this 100th unit that's being produced? Or what is the marginal cost at a quantity of 100? So we can think about what we have here that would help us understand this. And one of the things that I said before is that, well, if we see the firm is producing this quantity here, then we can infer, unless told otherwise, that this is the quantity that is profit maximizing for the firm. And we know that we have some rules about profit maximization, so we can think about those. And we know that in general, regardless of whether we have a competitive market or not, we know that profit is maximized at the quantity of output where the marginal revenue at that quantity is equal to the marginal cost at that quantity. Or if we're dealing with discrete units, we only want to produce units where marginal revenue, or how much we're incrementally bringing in, is at least as much as marginal cost, which is incrementally how much we're paying out, right? So one of the things we said, however, in a competitive market was that we didn't have to lower our price in order to sell more. So in a competitive market, marginal revenue, or the additional revenue we get from selling one more unit of output, is just going to equal the price. Because if I can sell as much as I want at a price of $10, then for each additional thing I sell, I'm going to get on the margin $10 coming in. So we can say here, in our competitive market, that in fact our profit is maximized at the quantity where price is equal to marginal cost. So then if we go over here, we said we already figured out what the price was. So it must be the case, if we're profit maximizing, that our marginal cost at this quantity also equals $10. The next part of the problem asks us for the firm's average variable cost. So we should be able to get that from what we have here. We might just need to be a little bit creative or take multiple steps, right? So we can start by thinking about what average variable cost means. So we have a formula, and we can say the average variable cost is equal to total variable cost divided by quantity. And we say, well, maybe this is helpful because we have quantity. We know that that's 100. So then, well, we sort of just turned this problem into needing average, total variable cost rather than average variable cost. So, well, maybe we can take this a little bit further. And I notice that total variable cost is just total cost minus total fixed cost, right? Because, for example, if I were to say, I know that total cost is equal to total fixed cost plus total variable cost. So it must be the case that total variable cost is equal to total cost minus total fixed cost. So I could say here that average variable cost is then just total cost minus total fixed cost divided by quantity. And now I notice it seems like we're sort of making progress because I know quantity and I know total fixed cost, which is just 200. We have that here. So now I just have to figure out what total cost is. Or I could notice some algebra with this fraction, and I could notice that this is going to be total cost divided by quantity minus total fixed cost divided by quantity. Total cost divided by quantity is just average total cost, which is something that we have, right? So you didn't have to know that average variable cost is equal to this right away. Maybe you could have noticed that average total cost is equal to average fixed cost plus average variable cost. So it must be true that average variable cost is equal to average total cost minus average fixed cost, which is actually what we're saying here, right? But you'll notice as long as you know what all the cost formulas are, it doesn't really matter in what order you choose to put them together, that you'll eventually get something that's in terms of the quantities that you actually have if you're given proper information in the problem. So now we can just plug in, right? That we can say average total cost we found out was 8. So So we just put that in here. We said total fixed cost is 200. Just put that here, and we said quantity was 100. So this just leaves us with an average variable cost of 8 minus 2, which is an average variable cost of $6 per unit. The last part of the problem asks us, is the efficient scale of the firm more than, less than, or exactly 100 units? So, okay. That seems to be deviating a little bit from the other things that we've talked about here, but not too much. So we can start thinking about what this means, and the first thing we have to do is make sure we're comfortable with what efficient scale means. So here, this actually has to do with the cost curves. So I'm going to quickly make a little cost curve graph for us. We've got quantity, individual firm quantity on the horizontal axis, and dollars per unit on the vertical axis, because we're going to be talking about average and marginal costs, which are in terms of dollars per unit. And we usually see an average total cost curve that's U-shaped like this, and a marginal cost curve that at least eventually becomes upward sloping. And we see that marginal cost and average total cost intersect at the minimum of average total cost. Okay. So then we have this idea of efficient scale. What we can see and what that means is where are we producing at lowest average total cost. So we could say that our efficient scale is at this quantity here, right? So we said, okay, we've made progress, because now we just want to be able to compare this number to 100. And then we say, well, that's weird, because it's unclear how we would actually do that. But let's think about what we know. Again, it's become sort of a reasoning exercise. And we can notice, for example, we can notice a few things. We can say, we know the firm is experiencing positive economic profit. So specifically, we know that price is greater than average total cost. So that even tells us that our price, even knowing nothing else, has to be somewhere up here, right? Because if the minimum value of average total cost is here, and our price is something bigger than it, so our price is up here somewhere. And what we also know is that this price that hits just the bottom of this average total cost U is the, I'll call it the price where profit equals 0. Okay. Because this is the price where, if you think about it, we have our profit maximizing rule, price equals marginal cost. It's going to be producing this efficient scale amount. But price is also going to equal average total cost at this quantity, so economic profit is going to be 0. And we know, not surprisingly, that as price goes up, profit goes up. As price goes down, profit goes down. Hopefully that makes intuitive sense to you, because a higher market price is better for sellers, and a lower market price is worse for sellers. So we can see here, if we're making a positive economic profit, again, that's telling us that our price has to be up here somewhere. So let's just say, let's pick an arbitrary point here. And we say our price is $10. So let's say $10 is just somewhere here. It doesn't really matter. That's going to help us make our point. Okay. So our price up here is $10. We know that the profit maximizing quantity that the firm is going to choose is the quantity where price is equal to marginal cost. So it must be that this point where price is equal to marginal cost, pull this down so you can actually read it, is our Q star of 100 units, right? So coming back to this specific question, now we can actually answer this. It says, is the efficient scale of the firm more than, less than, or exactly 100 units? The efficient scale of the firm is actually less than 100 units. and the firm is producing at a higher cost than it could, right? That the average total cost at this quantity is bigger than the average total cost here. Not by a lot the way that I've drawn this, but still. But it has an incentive to increase its production even though it's increasing its average total cost, because the revenue that it can get from doing so makes it worth it.